All right, so now that we went over inverse functions, let's bring some calculus in. So let's talk about derivatives of inverse functions. All right, so some properties here. So f is a function, and it has a domain, some interval I, who knows, and f has an inverse function. Then the following are true. If f is a continuous function, then its inverse is a continuous function. Think about the graphs, guys. So if we have a function that has some sort of inverse, who knows, and it looks like this, it's continuous, and we take it and reflect it over the line y equals x, it's still going to be a nice smooth curve. Like, it's not going to add in any sort of corners or anything. It's still going to have the same shape. The shape's just going to be a little bit different. It's going to be flipped over here. Right? If the original function is increasing, then the inverse is also increasing. Notice this function's going up. The inverse here also going up. If this function was originally going down, then its inverse would also end up going down. And if we're differentiable at some point c, so like here c, it has a derivative, it has a tangent line. If we look over here at that, let's see, f of c would be down here, so it'd be like back here would be the point. So over here, we'd still have some sort of tangent line. All right. So where one has a derivative, the other one has a derivative, if we flip the point backwards. All right, so let's take a look at some of this stuff. All right, so if we're being asked to find the slope of the tangent line at these points, well, the first thing we're going to need is the derivative. So f prime of x is 3x squared. So that means the slope of the tangent line at the point 1, 1 would be f prime of 1, which is 3 times 1 squared, which is just 3. If we look at the point 2, 8, well, f prime of 2, the x value, is 3 times 2 squared, which is 4 times 3 is 12. So 12 would be the slope there. And if we go a little bit farther, 327, and we look at the derivative here, f prime of 3, we'd have 3 times 3 squared, which is really 3 to the third, which is 27. Erasing, there we go. 27 is our slope. All right, now, here's our inverse function. So g is the inverse of f, right? It's the cubed root is the opposite of cubing. So g prime is 1/3 x to the negative 2/3. Or if we want to write that in an easier way to work out, it'd be 1/3 times the cubed root of x squared. All right, now we're going to look, and this is f inverse prime is another way we could write this. So now we're going to look at the points, but we're flipping them around. So remember, with the inverse function, the points get flipped around. If it's a point AB on F, then it becomes a point BA on F inverse. All right, so let's look at G prime now of 1. So that'd be 1/3 times the cubed root of 1 squared, which is just 1/3 for our slope. Let's look at G prime now of 8 as our x value. We get 1/3 times the cube root of 8 squared. All right, well, we could do the cube root of 8, and that would get us 2. Square it, that's going to give us 4. Or we can square 8 first and get 64, and take the cube root of 64 and get 4. Either way, we get 3 times 4 on the bottom, which is 12. So we get 1/12. 1/3 and 3, 1/12 and 12. Wonder where the next one's going to be. Any guesses? So let's try G prime of 27. So it'd be 1/3 times the third root of 27 squared. So again, we can take the third root here first. Third root of 27 is 3. 3 squared is 9. 9 times 3 is 27. So it's 1/27. Are you noticing a pattern? All right. It looks like if we take this derivative and just put it on the bottom over here, then it's going to give us the same answer. So it looks like the derivative of the inverse at the y value, or maybe the b value, we could say if we're looking at a point a, b, is equal to 1 over the derivative at the a value. It looks like that's what's happening. All right, the derivative at the a value is this guy, 1 over that, yep. All right, and here's that rule right here. All right, we switched a and b around the other way, but again, we can do that any way we want with the points. That's fine. And if we do it with x's, here's it with x's. So the derivative of the inverse is always equal to 1 over the derivative of the regular function evaluated at the inverse of the original x. So this right here is usually your y. All right, that's usually what we call that. All right, so if we find the original y value, we can just plug that into the derivative. So we want to find the y value, and then we want to plug in the derivative. All right, so what's the value of f inverse of x when x equals 3? All right, well, just f inverse. We're not doing anything. So we want to know what's the value of f inverse at 3. So that means f of x will be equal to 3. So we want to know when 1/4 x to the third plus x minus 1 equals 3. Let's see, we add the 1 over, we got 4 equals 1/4 x to the third plus x. What happens if we plug in 1? Nope, that's not going to work. What happens if we plug in 2? Hey, that's going to work. So just by inspection, I just tried a couple numbers. X equals 2. We could have also graphed and see. We could have multiplied by 4 if that might have helped. But it looks like we're getting 2. And I guess not necessarily x here, but our inverse value is 2. So f inverse of 3 is 2, because the point is 3, 2. Well, actually, I'm doing that backwards. 2, 3. That's the point. So that means if we go backwards with 3, we do get 2. Okay. What's the value of f inverse prime of x when x equals 3? F inverse prime, the derivative of the inverse, at 3, I'm just going to follow this here, is equal to 1 over f prime of the inverse value of 3. All right, well, the inverse value of 3 is 2. So that means we're getting 1 over f prime of 2. So we just need to take the derivative at 2. So we take the derivative, we get 3/4 x squared plus 1. And we plug in 2. 3/4 2 squared plus 1. So that's 4. 4 cancel. 3 plus 1 gives us 4. So the derivative at 2 is 4. So that means the inverse derivative at 3 is 1/4. So we switch the point around, and then it's the reciprocal. All right. Yep, there it is. 1/4, 4. All right. So can we do this now from a chart? So we're going to follow the formula here. F inverse prime of 3 equals 1 over f prime of f inverse of 3. We want to see what's the y value here. Then we want to know what's the function there. So what's the y value at 3? Well, it looks like it's 1. So that means 3, 1 is a point, or f of 3 equals 1, or 3 equals f inverse of 1. And vice versa, by the way. Goes backwards too. So 1, 3 is a point. So f of 1 equals 3. So 1 equals f inverse of 3. Hey, that's the one we wanted right there. So sometimes I don't always get it right on the first try either, guys. But there it is. So that means this is going to be 1. So now this is just going to simplify to 1 over f prime of 1. Yeah, tried the wrong point first, didn't work out. Tried another point, it did work out. So now I'm getting 1, and I want f inverse of 1. So at 1, the derivative, f prime at 1, is 5. So we're getting 1/5 is the derivative of the inverse at 3. I know it seems a little tricky. It's just practice and formulas here, guys. And there it is. All right, so some more inspection. So if f equals x squared for x greater than or equal to 0, show that the graphs of f and f prime have reciprocal slopes at the given points of f. So we want to know what the slope is here. So we're going to find the derivative, which is 2x. The inverse function here would be the square root of x. So that means the inverse function's derivative would be 1 over 2 square root of x. So let's see. If we plug in 2 here, is 2 times 2 is 4. If we plug in the opposite point here, for 2, then the derivative of the inverse at 4 is 1 over 2 times the square root of 2, 1 over 4. Checks out. We did this before with x cubed, but now we're just doing it again with x squared. All right, same with this guy. If we plug in f prime of 3 would be 2 times 3 is 6. If we switch the point around, 9, 3, and we plug into the inverse at, prime, the derivative. At 9, the y value, we're going to get 1 over 2 times the square root of 9. So 2 times 3 is 6. We get 1/6. Hey, it matches. And there are the graphs. They also match. Slope of 4, slope of 6, slope of 1/4, slope of 1/6. Reciprocals. All right, here's another one for you to try. If you want to pause it, that might be a good thing to pause it and give it a shot. But again, we're just going to try and follow the formula here. So it's 1 over f prime of f inverse of 10. So to find f inverse of 10, we need to know f of what value is going to equal 10. So we're going to take x cubed plus 2, set it equal to 10, subtract 2. We get 8, take the cube root, we get 2. So that means f inverse of 10 will give us back 2. Right? We had the point 2, 10, so that means on the inverse we have the point 10, 2. All right, so now we can just simplify this and say now this is 1 over f prime. F inverse of 10 is 2. We got it right there, of 2. So now we need to find the derivative of this guy and just plug in 2. So now we take f prime. It's 3x squared. F prime of 2, 3 times 2 squared. 3 times 4 is 12. So we're getting 1/12. There it is. All right, so that's inverse functions. Remember, if you get a little confused or a little lost, that's okay. It just takes some practice, and just remember the formulas. Just keep going back to those formulas, and that'll get you through. And that is it for inverse and derivatives. The other sections are easier, I promise.